Okay, after much deliberation, we're at problem number 8. We've deciphered it as b. How did we break this down?
Make first look at your last term and then
Yeah, so this is 1 here, right? So this is the b term. So then we know that E is wrong for sure, right? All right, what else?
make sure you don't have a delta x included.
Yeah, see, this is confusing here. This is an approximation. These are the exact. All of these are exact, so you're not going to have the 1 over 20s here.
So it's an approximation that has
Delta x in front of the actual integral value. And then lastly, so we have between b and a. Now, how the hell do we pick it? Any ideas? What do we think? Yeah, between b and a, like. Yeah. Oh, right. The last one, if you plug 1 in here, should be what? 1 over 20. And this is what? It's just 1 or 1x, right? Versus just 1 over 20.
Oh, so that's why it's only 2 because they calculate. If they're looking at b,
Yeah, it'd be 1 over. Because if they plug 20 in here, that would have been just the 1 value. No, it would be 1 over 400 again, right?
And it would be 1 over 28?
No, it would, I'm sorry, it would be,
Oh, it would be 400 over
20. 400 over 20.
Yeah.
20.
That would be 400 over 20.
Oh, right, yeah, it'd be 20 over 400, my bad. Because you plug it in. Because, oh yeah, don't look at this one, look at this one here, right? And you're plugging in 1 over 20 here. Oh, you're plugging in 20 over 20, which is 20 over 400. Okay, sorry, I got confused. Which would just give you this one here. All right, so in here, so we've done it. I've done a mini example here, and I will cover up the answer, and we'll see if we can get it. Yeah, I just did it. We just did it here. Yeah. All right. So, can you do this one?
What's the?
All right. This is it. So you have to find what is this integral, right? So you know the last limit of integration is 10 pi over 10, so it's going to be pi, right? You know your function is sine of blah blah, right? And if you reduce this here, you're going to get pi here. So all you have to figure out are your limits of integration. Clearly, what is delta x here? How do we know the which one? Oh, because you see here, like at the end, because it's a Riemann sum, the last one is going to be the last. It's going to be this one here, right? And 10. Yeah, because 10 pi over 10 is just pi, right? And then the first one is you say, well, look, this is delta x, right? So if you subtract it from here, that would give you your first limit of integration. Because that's the way, if you look, that's the way a Riemann sum works. So this is going to be 0. And then lastly, you just need your function here. Well, no, a Riemann sum is like a combination of, it's like a combination. A Riemann sum in of itself is, they should specify as to which one it is, but this is an approximation using a Riemann sum. And then here, we would just find what goes in the values, which is just going to be x here. Why x? Because it's the only thing that fits, really. Why? Who can answer that?
Because of 110 or pi over 10 is your delta x, like what you add each time.
Right. Each interval is delta x.
Because I want to add, well, in this case it would be 10 equals 7.
So like each time, Aaron, you're adding pi over 10 to whatever your value was here. So let's just say like, if you do, let's just say my function was this. If it was sine of 2x, right? Then it would be what? If my function was sine of 2x, and let's just say it's again pi over 10, right? So the first one would be sine of what? And sine of
No, we have to 2 pi over 10.
2 pi over 10. Why? What? Anybody?
Because you know that you're factoring out, because you plug in, you add pi over 10 to 0.
Yeah.
Then you get pi over 10, but your function is 2, let's say multiply that times 2. You just get 2 pi over 10.
Right? Now, what's the next one? So then,
The question I'm asking is why do you add it to your first one? Why do you do this transition?
that's a good question. Why? I mean, that's because in a Riemann sum, unless specified otherwise, so you could do RRAM or LRAM, but